Okay, so from here you can see I got some spam from my auto robot. So if you open this link, this is nice page to see about Autodesk and Revit updates, programming stuff regarding BIM field and so on. So I highly recommend to follow this page for some interesting things about building information modeling. And for this robot, I used Power Automate, so it's a special feature in Microsoft environment. And using this automated robot, you can automate some announcements from the pages. If you post new information on the page, it can be reposted on Teams and so on. Also here we have artificial intelligence builder, and my robot part is here, and something is damaged, so I see a lot of posts from the same thing. So now I will check analysis. Also, you can check in your student version. Maybe you have also access to Power Automate, and maybe you can do some interesting automation stuff for yourself or for your members, classmates. Okay, so I see I got each day 47, 48 announcements, 184. So something is not good. And I will turn off this part and later try to fix. So my task using these robots to inform you about latest updates on things, what is happening around the world. So let's say, like I told, this is a nice page, the building coder, and also another nice page to follow information is the Revit blog. And if I click edit, and you can go to Autodesk blog here. And in here you can find also a lot of interesting information, what is happening in BIM world, and especially in Revit. So I also recommend to follow this one. Okay, so let's jump to our course. Let's open our project. So before I start, let's pause Cloud Platform. And let's jump in the project. And also let's check our planary plan. So in the vertification part, I put it all the tasks which should be done this week. So if I filter by this week, so here I have all the tasks I should do this week. It's 36 tasks. Some tasks is done quite easy because if you create walls, you complete one card and so on. So I think it's quite easy to accomplish all the tasks. Okay, so if we look to the filter, I will turn off filter and try to follow all the things. So now we have week number 9, and if you want to see classification codes for all the elements in our plan, you can click View References and click Classification Codes. And in here you can see Lab Work 1, Lab Work 2. So regarding Lab Work 2, we should finish foundation plan and underground floor plans of structure and architecture. And next part, for today is to see how to do wall modeling part and column modeling part on top of the ground. So I will speak more about walls, windows, doors, curtain walls, and internal walls, doors, rooms, spaces, and a little bit remind on the design of the drawings. So week number 9 is for lab work 2 to submit, and next submission will be for the floor plans on the ground, and later we will jump to floor constructions, floor frame, and roof frame constructions, and also roof. And lab work number 5 will be for the stairs, and the last one will be lab work number 6. So it means on week 12 we will finish modeling and creating basic drawings, and later we will have a couple of weeks to accomplish all the to fix all the mistakes, to correct the model errors, and so on. So practically 4 weeks for updating models. So it's good practice to do all the modeling part as soon as possible, because later in the other courses or in other lectures you will have all the final exams and other things in the end of the semester, so it will be very busy time. So it would be nice to do the main part as soon as possible. Okay. Also, if we look to our tasks in Teams, we have additional tasks like 2 homeworks, homework and homework number 2. So homework assignments you can find in assignment section, and here we have one of the homework. It's called reinforcement concrete structure drawings. So final drawing after you finish this task should look like this one. So here you have all the main dimensions and other parameters. So here is schematic drawing, because we have letter L representing length and so on, and the final version should look like this PDF file. Yeah. So final version should look like this one. Okay, and maybe this lecture I will explain how to do this part, and later we will jump to main project of ours, of our building. So based on your task number, you select the data from this table. You choose your number, and your number is provided in the images I posted in our main chat. The workflow should look like this. You just go and take all the data from here. You download the PDF file and you can open it side by side. You can also download the image file and also Excel file. Or you can open Excel file online if it's possible. And now I will try to simulate, let's say, the last number, 13. So for this task, you can use the same template. Of course, it would be nice to have a specific template for this homework, but at this moment, we don't have such one. So you just click New, create new project. Also, we should go here and select the template. Click open, a new project. So in this project, I will not need any of extra drawings. I will need only one drawing. So I can leave only one drawing in here. So let's say drawing like this one, and I can delete all other things. Okay. Delete. Now in 3D model, I also can just select and delete all other things I don't need. And for the coordinates, I just need to acquire reset share coordinates. I reset it and get 0, 0. So in this case, I just total 0 coordinates. And for the views, I can organize all the views, and practically I don't need any of views. I can also delete all the views. So I can delete views by selecting views from the list, or I can create schedule for views and do this deletion in the schedule. Now I will just use this technique. Make the callout view independent. Delete the callout view. Okay. So now you can see I just deleted everything. I have only 3D view. Everything is cleaned, and now I will try to model the part which I need. So I click save. So in this case, I will select the same name and rename this part homework number 1. For the project code, I will leave the same project code. Let's say it's a part of our building. Options, I just stay the basic options and click save. So first things what I need to accomplish is to create guidelines and levels. So first I will need to create a plan. So I select structure plan and elevation for level. So in this case, I will select 0 and structure plan level 0. So in here, I can delete all these extra objects. I don't need them. Here, I should also use this plan for work in progress. Nope. And I would like to see my coordinate system. So in this case, I will select site and turn on all parameters. Basically, I can expand and turn all things. Click apply. Okay. So property line is also not needed. And on this location, I will go to architecture, select grids, draw basic grid line. So on this grid line, I will create my beam. Also on this grid line, I will create section. So building section. Just coordination section like this one. Okay, so it's not visible here. So section. Let's change section parameters to none and change discipline to structure. And also in here, I should turn off all the filters off. Now I have section here. Next part, I will create section other side, like this one. So I have two sections, one grid line, and if I go to the view from the side, I have a level. So now I prepared my basic planes or work planes for the work, and now I can create structure, and I need to create beam. So I will just use a rectangle beam and draw a rectangle beam. So for the view range, I will just put unlimited because it's work in progress. So now I can see my beam. I put basic dimensions on my beam so I can follow all the changes. And also I would like to put the beam in the beginning of my coordinate system. Okay, so I just go here and see, let's say I will filter only task which is related to me. So here, length will be 5 meters 900. So I click on my beam and click here, 5 meters 900. So it shortens from both ends. So in this case, I need just use move tool and move the beam to needed position. Move. For view settings, I just turn on thin lines so I can see everything in thin lines. Okay, so the length of my beam should be 25, so 875. Yeah, total length is 500. 5 meters 900. So B and H is 150, 360. So I just click on the beam, click edit type, duplicate. So weight will be 150 and here 360. So B 150 and here 360. For concrete, I will select concrete, high density concrete. Okay, I put again the dimensions, okay, 150. So if I go to section, this section also I should turn off and change coordination. Section 2. $360, $150. Okay, so my geometry is done. Next part is to do reinforcement. So all these numbers represent reinforcement data. So N represents how many reinforcement bars should be in a transfer position. T represents the spacing between the bars. And letter M represents also some spacing, but it's specially put it here. So if you follow all the instructions, you can know it's not needed. If you don't follow instructions, you will try to find what purpose is this parameter for, and it can get you some let's say errors of some things. So my idea is, if you see this parameter and you don't know in which position to use it, you should ask questions in our chat group, and I can explain the usage. And the bar size. So to understand all these parameters in which location to put, so in my plan view, I will put the image. So I click insert, and let's link image, and I will link image from here. So I will create folder homework. And I will put all the files which I downloaded over here. So I select this image, I put it here, so I can see all the basic data. Okay, so L is done, and H is done, B is done. So now regarding reinforcement. So the spacing between bars is letter T. How many spaces is letter N? And letter M represents if we have, let's say, how to draw it, just maybe simple annotation tool. So normally beam reinforcement goes 3 segments. So in one segment we have dense reinforcement placement, and in other segments we have not so dense. So let's say in this location I have reinforcement bars which is placed quite dense. In this part, based on mechanical calculations, this part doesn't need so much reinforcement bars, and on the last part I have also dense reinforcement. So it means if I put my beam on 2 points, so let's say one point is here and another point is here, my beam reinforcement looks something like that. So now let's, for simplification, I made this beam just 1, like this one, and just 1 spacing for all the bars. So it means if I put it here, so I have 1 spacing like this one. So in real projects, reinforcement should look like this one. In simplified version, we are using this one representation. Okay, so now let's try to do reinforcement part. So for reinforcement, I go to structure and have reinforcement tools here. So to put reinforcement, I can use also automated tools. So in internet, you can find a lot of Revit add-ins which can do reinforcement automatically. In our homework, I invite to do it manually to train how to do it. Okay, so for basic view representation, I will use the scale which is represented here, 1 to 10. So all my views will have the same scale. Let's select all views and select scale 1 to 10. Also, I would like to use scope box so I can easily organize all the views. So in this case, I select scope box and draw a scope box around my beam. Of course, it's not visible, so I just expand all and turn it on. And for skull box, okay, do the same here. Expand all. Also expand all. And now skull box is quite large, so I just try to optimize it. And now for all the views, I select the same skull box. And all views are nicely cropped, and I can see only the main skull box. So now let's try to place reinforcement. So now to put transfer reinforcement, I should check my task information. And where I have image, raster image. Because I'm using Skullbox, it's not showing. Okay. So my transfer reinforcement is diameter 8, strength class is 400s, and position is 3, and the distance, the protection layer of concrete is C, and for the C, I should check my task information. So regarding protection layer, I should use 25 millimeters of protection layer. So from all sides, protection layer is 25 millimeters. Okay, so I have this information and I can start creating the rebars. I click rebars. Rebar shape definition will include hooks. Okay. And now I click this part to see all the shapes which are possible in my template. And in this case, I will need to select, let's say, a shape like this one. Now from the rebars, I select rebar diameter 8, 400s. And now I need to I think I need to activate all the layers, all the groups. Let's try again. Okay. Yes, now it's visible. So diameter 8, 400. And I put it here. Let's save progress. Now protection layer is, I should select protection layer from this list. We have special codes which represents some aggressive environment. And for my bar, okay, edit type, radius. So material should be reinforcement. Eight. Metal. Okay, so I should select metals, I think. So in this case, steel, I will choose steel. Okay. And for the shape, maybe the shape is not nice. I can try to look for other shape. No. Yeah, so I think this shape is the best solution in our case. And I just extend it to needed position. So this part I don't like, and maybe I can do some edit bars. No, okay. So the reinforcement is placed. Now I need to put reinforcement inside all my beam. So in this case, I will go to 3D model and select transparent option. So here I can see my bar. If I want to see 3D bar, so I click Find, and I can see 3D representation of my bar. I select the rebar, and I select it will be number of spacing. And I put the information from my task here. So spacing should be 250. So spacing 250. And I need 10 spacing elements. 10. Okay, maybe it's too much, too little. So in this case, I will select fixed number, minimum clearance. Yeah, minimum clear spacing 250. So this option should be selected because, like I mentioned, data N and M is coming from more complicated tasks. So in this case, we just organize all the rebars in all the beam. And I just drag this line from here and to here. And I have nice representation of rebars. And of course, I need to put 25 millimeters from both sides. So I need to move it a little bit inside. And let's go to the section and let's check if all this info is nicely presented here. If I use 3D medium representation, so it shows in 3D view 2D lines. If I use fine, it shows all the rebar with all the hooks, and if I want to put dimensions, it's better to use medium representation. Okay. So I need to put 25 millimeters. Okay. On the side, 25 millimeters. Okay. On the bottom, 25. Okay. And from this side, 25. So the spacing from the sides is okay. And now the clear spacing is 266. So I need 255. So it means I need to change number of web spacing, maximum spacing, fixed numbers. So I need to go back to this one. And in this case, 23 rebars, I think, is in my case. Okay, so this is 250. Okay. And 24 rebars. Okay. And now I have 117 from one side and 25 from another side. So I need 2 plus 25 multiply. So I can write the formula here. It's right, and divide by 2. So 71 from here. Okay, what? Okay, it's just dragging one bar. Move here. Move 71. mistake. Try one more time. 71. Okay, 71, and here 71. So now my rebars are created correctly. Another rebars should go through all the beam like straight elements. So in this case, I have the bottom bars 16 diameter. So if I go to the plan view, in the plan view, I can see rebar diameter, rebar position 1 is the which is presented in the table. So bar 1 is here, and top bars are represented here, diameter 10, 500s. So let's try to model these elements through it. Let's go back to the section. Let's click bars. Let's change the bar type to 10, 500s. And in this case, I will use first position and will use parallel to cover and just put rebars here. And I will use diameter 16, 500s and put his rebars in the bottom position. Let's go back to 3D model. So my main rebar is created. Now I need to put hooks for my for lifting the beam. So in this case, I will draw some reference lines like this one. So the distance should be according to the task. I go here. So the distance to my lifting part 350. So I click section, select reference line, click 50. So this is the center of my hook. And now the dimensions of this hook is like this one. So to model it, I will try to zoom all parts, and so I can see all the needed data in all the views. So I go to my section, click rebar. In this case, I will sketch rebar. So pick host for rebar. So I select my beam. I select this part and draw lines like this one. Okay, so now the center should be moved to the reference line, and now the dimensions. So between these lines 60, okay, between these lines 56, 56. Now other side dimensions. So in here I should have 60. I can trim extend. Oh, it's like that. 60, 60, and length is h plus 25. So for my length, I just put dimension here. So I know my beam is 360 and I plus 25. So I go home, click equal. So my size should be 385. Now I choose diameter. So diameter is 8, 888, 400s, 8, 400s. Okay, and then I can try to click finish. Cancel rebar shape, delete rebar. So, okay, let's cancel. So it means I have some issues because it cannot create this rebar shape. So in this case, I think the problem is standard bend diameter. Standard hook bend diameter. So I think the problem is this number. And in this case, let's try to change it maybe to 60. Apply. Okay, I see it's better. I'll change to 32. Now it's much better. It's important part. It's mostly according to diameter of steel rebars, and the standard bend diameter should be taken from standards. So rebar standard and Eurocode, bar shape codes, and list of standards. So we should follow regulations from. So here is the standard shapes of rebars according to Eurocode and ISO standard, and radius for bending is depending also on the diameter. So for diameter 8, minimum radius is 16, and minimum diameter of bending forward is 32. So it means object around which I can bend is 32, and radius, internal radius of this part is 16. So it means I can also update my information in my project. Okay, so Eurocode and related standards. So from these standards, I should follow instructions about rebars. And the Eurocodes you can open also in our library page, or I can just put this data about hooks diameters in our homework number 1 in conversation. So you can check this info here. Okay, so I can type here maybe 16. Diameter, so not radius, 32. Okay. And now I can see some black lines here. So this line shows what the bending is okay. It suits the requirements. I can click, and now my rebar is created. Now I need to move the rebar hook down to this position. And if I look in 3D, so now my rebar is located here, and I have some issues. So my rebar is collisioning the transfer reinforcement, and also I can easily lift the bar, and I need some special connection here. So in this case, I will need to use rebars, straight bars, and use the same diameter and put them here. Also, I should double check if these elements is 8. Yes, 8, diameter 8. And of course it should touch, so I use the align tool and align it so it nicely touches. Now these two bars will not let me pull out this hook out from my beam. But still I have this problem because bars are colliding. So in this case, I will need to make a decision. Should I move the objects to the right or to the left? So in this case, I will move it maybe in this position. And now my size is changing, 347. So in the comments, in the notes of my drawing, I will need to explain why my distance from the end of the beam is not 350. Because my rebars are colliding, so I made a decision to move my hook to the left side, so I avoid the collision. For all these three elements, I should use a mirror tool and just mirror it based on my beam on another side. Okay, so my reinforcement is done. My beam is done, so just need to compose the drawing. So for the drawing composing, I need to do all these parts. So let's check out how the drawing looks like. So I have these views in my drawing. Main view from the front, main view from the side. So the beam views from the front and from the side. Beam in cutted mode, so beam cutted in half, and two beam views with cutted views showing reinforcement inside the beam, and separate drawings for reinforcement. So main views 1, 2, 3, 4, 5, 6, and the hook view. Extra views is these 3D views, which shows 3D reinforcement with different colors and so on. And so these are extra. Other things what you should include is reinforcement shadow. So it means reinforcement shadow for the reinforcement and for the concrete. Okay, so let's jump in Revit and let's try to compose the drawing. So now I save the project. I click View, Tab View, and I will try to put all the views here. So all my section views is work in progress. Work in progress. So now I will need to create clean views for my drawing. So now also I can follow the view names here. So beam front, beam side. So it means I inherit the name beam front. No. And duplicate beam. It's plan view. So I don't need plan view. I need all these sections, I think. And also I need extra view, which shows beam from the top. And beam from the front. So maybe I can use elevation. Or also I can use section, but in this case I will try to use elevation. So I will create this one. And in elevation, I remove the template, change discipline from coordination to structure, change scale to the 10, put scope box which I'm using. So beam, B1 beam, and I can go to elevation view, and in here I can see my beam. So instead of realistic, I will use hidden line representation. I will use medium. So in this view, I don't need elevation. I hide the category. Okay. So from front. Now I need beam from the side. So I also should go to beam from the top and repeat the same task. So I just put the symbol here. Delete this one and move section plane here. So it is inside the scope box. And use the same settings. B1 and template. Change scale to 1 to 10. Change discipline to structure. And in here, beam side. Right. So now I can put these beams here. Okay, I see it's quite large drawings. In this one also I change it to medium representation, hide the lines. I don't need elevations, I hide it. I don't need grid lines, I hide grid lines. Okay. Now I need to put the name with name here and the name for this one with this bubble. And now I need to make it more compact. So to make this part compact, I click on the crop region, and in here I see these zigzag objects. I click on it, and I nicely can move beam and create shorter version. Because my beam through all the length is the same size, the same formation, so I can optimize it and make nice view like this one. So the name goes in the middle of the view. If it cannot be in the middle because it's colliding with some objects, we can move it to a little bit to the side. This one goes also in the middle. And I move both views down a little bit. Okay, so I need other views. So I just, in this case, I will use section views. So beam with rebars, front, with rebars, and repeat the same steps. So I duplicate these views, duplicate, and write rebars front here, rebars section. So in rebars view, I just turn off all elements and I just go structure rebars. I see all the rebars. I hide categories of levels and grids. And in rebar font, do the same. Turn off all elements and leave only the rebars. And in annotation, go to level and go to the grids, turn off it from here. And do the same like I did the other part, so I can have nice short view and move it here. For this, I should also change view representation to hidden lights. And also I need the hook. So for the hook, I will use a little bit different technique. So in this case, I will select the hook and I will create assembly. So in here, I will type hook. So hook K1. And this creates assembly in here. So I have assembly, and in assembly, I can create assembly views. So I can select, let's say I want to create all the views. And for this hook, I see the scale is 1 to 10 and the scale is 1 to 10. And I can create, let's say, special sheet and special assembly for my hook. So I can nicely organize and do special view for the hook. So let's say the hooks, all the views, and I can change view template. Okay, scale 1 to 10. Fine. Structure line. And in 3D view, it's I click tab, I select object, and this part should be active, so I can change settings in 3D view. If I want to change 3D representation of this one, so I can go here and click this one and select, put the check marks on all views so I can see it in 3D view. Okay. It should be 3D. Why it's not? Let's try one more time. Visibility settings. View on obscure. 3D view. Okay. Oh, maybe I need to rendering settings. Okay, so for this quick representation, I don't remember how to make it 3D in this view, but in other views, so I can see, I should see my rebar here. Sure. It's turned off. So in this case, I should use reinforcement. Visibility graphics. Visibility rebars. Yeah, so it's showing here. Okay, so in this case, I don't need any sections. So I will use this one and then put needed dimensions here. So dimension style is not correct because it cannot go like on arc, it should go on line, and line should be away from origin. And the text should go on the top arrow, 90 degrees, always from origin, beyond witness line, and leader tick mark. Text location above. Yes, like this one. And text size, in this case, let's make duplication. And text size should be 2.5. 2.5. And flip the dimension line extension. Okay, let's click like this one. Yeah, so the text should be on the line. This spacing is a little bit too big. Let's try to modify it. Text offset 0.5. Apply. Okay. Now it looks much better. And the text goes to this line. So tick mark here and this line. Maybe we can turn it off like this one. Okay, this part is done. And I should use annotate tag and tag the rebar. And from tags, I select, I need to tag it with okay, so we have a lot of rebar tags. So I should find so it can be tagged with yeah, with these bubbles and you know 1 diameter 8. Length. Okay, so position, DL, position. No, this one is not good. Phone, no. Okay, maybe I will stay with this one. Yeah, so I should see the number here. And the color representation. Okay. close all the views I don't need. And let's go back to the paper space, and I just put the hook here. And on these views, also repeat the same task. White presentation, and views are practically put in place, so I can just do some additional tweaking. So if I see I will not fit all the views in this A3 format, so I can, I think, increase the sheet size a little bit more. So in this case, I think the sheet size is A2, so I can change it to A2. So now it's more space, so I can organize it easily. So the space should not be very large. It's better to have something like that. If you will move to close, it will close on all of this part. So it's better to move it and maybe just drag it by this one. Also, you need to put some specific components which should be used as break line. Break line. Detail break line. So we should use this symbol, so it shows in which location we are making the break line. And opposite, and also mirroring, don't copy, just mirror, and this should go. And it should look like this one. Now regarding dimensions, so for dimensioning rebars, we can use multi-rebar dimensioning tools. From here, I click on the rebars, it automatically puts total length of rebars, and sometimes it's better to dimensioning before you use this cropping tool. So in this case, I have this formula, so I should edit type and say tag family, no, show dimension text equal formula equal text equal values. So it can be like shown like this one, 250, 250, or it can be shown like equality formula. So for equality formula, you can go to here, and equality formula, you can type, let's say, length of segment, move up. After this, number of segments, move up, and you can click prefix, suffix. So it means I multiply it by by this one, and I get equal this one. So I can try to check how it looks like. So in this space, I need to put some spaces. So I click Edit, go back to Formula, and I can put space here, and also space here and here. And now it looks much better. Now I need to move this number close to this position. So if I make this closing part, my text is not in this hidden part, but it's normally readable, and I can manage this text. And later I need to show all the dimensions of all other elements. So in this case, the length of my main bars, also the distance between main bars, maybe distance to my top bars. It's not often used, but it can be used. And what is the distance between these positions, and also position of this hook. And also the extend from the main bar. And repeat the same here. So the main task is to explain the person who will try to make this bracket of rebars, how it works, and what objects should be added in which way. And if dimensions is not fitting, you should move it to the sides. And the same goes here. And if dimensions is colliding with objects or hiding the objects, so it should be moved to also to the side, and we go around all the object. And next part is tagging. So for the tag, I click tags and select what rebar tag I will use. So in this case, I can use example which I showed. So maybe the position and maybe length, or just position and like this one. And in this case, I like free end, so I can organize, click tab, and put the tagging on each object. If, let's say, this option is not good, just select all the views, all the elements, and try to change to maybe other solution like this one. Maybe this one is better. So here we have the length object, the diameter. I am not having the strength parameter as in example. But in this case, main part is this number, which connects everything to the schedule. And another part is, this part can be also found in the schedule part, so it can be organized easily. And regarding schedules, so we can check, maybe I have some YouTube video regarding scheduling. Create structural walls. Sheet legends, text notes, schedules. So at the moment I don't have here video. I can check it out in Autodesk Knowledge Network. And my contributions, product services, contributions. Yes, so here we have some video with some instructions. Reinforce concrete structure drawings. So in these Autodesk videos, it's nice because you can zoom in and you can see here all the items, dialog boxes, settings, files, products, which we used in the program. So if I click on, let's say, settings, automatically it shows all the things I typed inside the program. If I click on selections, so I see a lot of information in here. So I see the mouse movement. On the side, I see all the commands I'm using, and also I can use search rebar. Let's say I type rebar, and the program found 30 matches inside my video about rebar. So I can just jump to different positions and see. Let's say I want to see schedules. So regarding schedules, I also can jump and see how to do the scheduling part. Which parameters to put inside the schedule and so on. And I easily can move around and see all the things I was typing and so on. If the speed is too fast, I can just click the speed, half the speed, and I can see all the things, what I'm doing on the screen. So in slow motion. Also, I can create like video on the side, and I can go back into the program and I can do modeling part and follow the video instructions. From my experience, best to put videos on separate screen like mobile phone, tablet, or additional screen monitor, and it can save you some time because you can follow instructions and do all the things. So I will put this video inside our homework section. So basic functions I showed, how to create objects, how to tag them, how to make views, how to organize all the parts. In here I see the rebars, so I need to turn it off. I think I did a mistake because I used this part, and in this view I don't need to see the view. So beam front, beam. It's invisible. Why? Ah, okay. Oh, now it's hidden. Okay, nice. Yeah, so from here, you just need to have this shadow part. And yeah, these are recommendations for the homework. And after you finish, follow instructions and upload it in Teams and also in Trimble Connect.